Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela here, and today we are going to talk about option strategies. In this lesson, we are going to learn that option can be used at insurances to get rid of some financial risk. We will learn some option strategies and how to calculate the payoffs and the profits. The targets of this lesson: first, recognize that a long put can be used as an insurance strategy for a long stock position, and a long call can be used as an insurance strategy for a short stock position. Understand some option strategies can be used as tools to manage financial risk or speculate on price or volatility, including option spreads, color, dreidel, range, butterfly spread, and how to calculate the payoff and the profit of the option strategies above. Due to the duration of the video, I would have to separate this topic into two separate videos because it would be really long if I combine them in one video. So in this video today, we are going to learn number 1 and half of number 2. And the next video, I'm going to finish the whole lesson. Alright, first option as insurances. Remember that call prices increase when the underlying stock price increases, and vice versa for put prices. An option can be combined with the underlying stock to form various positions, including insurances. Let's talk about floor. A floor is an example that a put option can be used as an insurance. Suppose you own stocks of a bank and the stock price is expected to fall for some reason you cannot sell the stock immediately. In order to get rid of the fall in stock prices, you can purchase a put option as an insurance. Here for the unhedged payoff, it should be at T. There's a stock price at time T. The put payoff here is the maximum between K minus at T and 0. So for the put payoff, either you pay K minus at T or 0, the maximum between K minus at T and 0 at the time T. So the hedges payoff here is either K or at T, depending on whether at T is between 0 and K or greater than K. Here, remember the function K minus at T with the plus sign outside of the parenthesis represent that you find the maximum between this value and 0 to get rid of the negative value. So here, in case that at T the stock price is less than K, this K minus at T is positive. So K minus at T plus should be exactly K minus at T. Then we add at T here, we got K for the first case. Now, otherwise, in the opposite, if the stock price is greater than a strike, then K minus at T plus here should be 0. So the summation of the payoff should be ST. In here, K is called the floor, and this is a case of downside risk. Such an insurance comes with a price that, and that price is the put premium at 0, and that should be put option at time 0 PS0 KT, and this put option will accumulate to e to the RT PS0 KT at time T. So the minimum time T profit should be K subtract e to the RT PS0 KT. It's similar like when you buy a house or a car. If you buy a house and you want to get mortgage, then you need to finance. And in case of finance, sometimes you need insurance to support you in case you cannot pay for the house, or in case the house got damaged by disaster or any other reason that not from you. Similar for buying a car, you also need to get an insurance. So the same thing here when you own a stock of a bank, and we cannot expect whether we cannot foresee whether the stock price is about to rise or fall. So we need an insurance. We need an insurance in order to hedge away the financial risk. And similar to a floor, we also have a cap. A cap is an example to represent that a call option can be used as an insurance. Suppose you have just sold a stock. You will make a profit if the stock price declines, but you will suffer upside risk if the stock price goes up. So again, in order to hedge the rise in the stock price, you should purchase a call option as an insurance. Alright, so the unhedged payoff here is minus -t, because here you sell a stock, so the payoff should come with the negative size, right? And the call payoff here is -t minus k plus, right? So the hedges payoff here is either minus -t or minus k, depending on whether -t is between 0 and k or -t is greater than k. If -t, the stock price, is less than the strike, then -t minus k plus function should be 0, and the hedges payoff should be minus -t. If -t is greater than the strike, then -t minus k plus should be -t minus k, and then plus the unhedged payoff minus -t, we got minus k for the hedged payoff. And here minus k is the floor. Such an insurance comes with a price, and that price is called premium at 0. Is the call premium at 0. CS0KT. Alright, example 1. Suppose that you short one share of a stock index for $50, and that you also buy a 60 strike European call option that expires in 2 years for $10. The effective annual interest rate is 3%. If the stock index increased to $75 after 2 years, what is the profits on your combined position, and what is the alternative name for the call in this context? So here you short one share and you buy one call option. So when you short one share, you got $50, and when you buy a call option, you pay $10. So at time 0, at the initial time, you got $40. That is the initial cost, right? $40. Now after 2 years, when we consider time 2, we would have a payoff, right? So in order to find the profits, we need to look at time 2, and we need to look at the payoff and the initial cost. The profits on this combined position is the payoff plus the initial cost times e to the RT. So the payoff here, remember this is a cap problem, so it should be minus -t2 plus -2 minus k plus. And the initial cost, the future value of the initial cost is initial cost times e to the RT. E to the RT. So first, the stock index increases to $75 after 2 years. That means f of 2 at 2 should be 75, and the strike here is 60. Right? The initial cost is 15 minus 10, which is 40. So just use all of these numbers, plug into the equation. We got negative 17.564. That is the profit on this combined position. And the alternative name for this context is a cap, because you short one share of the stock index. And buy a call option. Alright, next, spread and color. First, let's get you to the bull market and the bear market. A bull market is when everything is great, the stock prices goes up. A bear market is when the opposite. A spread strategy is taking a position in two or more options of the same type. Maybe both of them is put or both of them is call. And a bear strategy is flipping the side and the payoffs. For the spread, we will have either a call spread or a put spread, right? So let's consider a pull call spread can be created by buying a call on a stock with a certain strike K1 and then selling a call on a stock with a higher strike K2. Remember that the call payoff is in a cap is FT subtract K plus, right? Here we consider three cases. When the stock price is less than the first strike, when the stock price between K1 and K2, when the stock price is greater than the higher strike. And we consider when we long a call strike K1 and when we short a call strike K2. Long here mean buy and short means sell. So remember the payoff in a cap is FT subtract K plus. So here first, if you consider when you long a call strike K1, if the stock price is less than K1, then ST subtract K1 plus should be 0 because ST is less than K1. When the stock price between K1 and K2, then ST subtract K1 plus here should be ST subtract K1. And also when ST greater than K2, of course ST is also greater than K1. So ST minus K1 plus here is exactly ST minus K1. Now if we consider a short a call strike K2, when you short this side, you have to flip the side. Because when you short, you get back money. So the payoff should come with the negative side in the front. So here, when you consider the stock price less than K1, of course, stock price is also less than K2. So at T minus K2 plus here should be 0. And don't forget the minus sign. When the stock price between K1 and K2, the stock price still less than K2. So FT minus K2 plus should be 0. And don't forget to use the negative side here because we are short a call. We are shorting a call. When the stock price is greater than K2, then ST minus K2 plus should be exactly ST minus K2. And don't forget to put on the minus sign in the front because we are shorting a call. And now the aggregate. We basically just add column by column. So first 0 plus minus 0 is just 0. The second case, ST minus K1 minus 0 is ST minus K1. And the last case should be K2 minus K1. So the payoff of a pull call spread in this case should be either 0 or ST minus K1 or K2 minus K1. The cost of this portfolio is the gap between the call option of try K1 and the call option of try K2, and it should be positive. Now let's consider a bull put spread. So now we switch to put option instead of call. So a bull put spread can be created by buying a put on a stock with a certain strike K1 and then selling a put on a stock with a higher strike K2. Remember the put payoff of a floor. In this case, it should be a floor because floor go with put and cap go with call. So here we have to, for the cap, we got FT minus K. For the floor, we got K minus FT. And don't forget the plus sign to notate this is a function. Okay. So we also consider 3 separate cases. First, when the stop price is less than the first strike, then the stop price between the 2 strikes, and when the stop price is greater than the higher strike. We long a put strike K1 and short a put strike K2. So let's consider the first one, long a put strike K1. When the stop price is less than K1, of course K1 is greater than the stop price. So K minus FT plus here is just K1 minus FT. When the stop price is between K1 and K2, so the stop price is of course greater than K1. So K1 minus FT plus here should be 0. When the stop price is greater than the second strike, then of course K2 minus FT plus should be 0. When we short a put, don't forget when you short, you have to flip the side of the payoff. Because long means buy and short means sell. When you sell, you have to have money, right? So here, when the stop price is less than the first strike, we use K1 as K, right? So K minus FT here, just K1 minus FT. With the plus sign, we consider a maximum between K1 minus FT and, in this case, we use K2. We use the maximum value between K2 minus FT and 0. Here K2, here we got FT less than K1. That means FT is also less than K2. So K2 is greater than FT. So this one becomes minus K2 minus FT in the parentheses. See that? K2 minus T, we use the negative sign up front. When the stop price is between K1 and K2, that means stop price is less than K2. So K2 is greater than FT. So K2 minus FT plus should be K2 minus FT. And because this is a short selling, so we have to use negative sign in the front. The last case, when the stop price is greater than K2, so K2 is less than FT. So K minus FT here should be 0. See that? And then we aggregate by adding column by column. So the payoff of a pull put spread here should be either K1 minus K2 or FT minus K2 or 0 depending on where the stop price stands. And the cost of this portfolio is the put option of try K1 subtract the put option of try K2, and it should be positive. Alright, now let's consider a bear strategy. A bear strategy is flipping the side of the payoffs. Here, we basically just flip the size of the payoffs of a pull strategy. Remember the pull call spread payoff should be a piecewise function. So if you graph the function, this is the payoff of a pull call spread, right? And the pull put spread payoff is also a piecewise function. And if you graph it, you have this graph. You see that? So one thing we notice here is the graph of them are similar, right? We basically can just shift one graph vertically to obtain the other graph. So we expect that the profits in the two cases should be the same. Now for the bear strategy. For the bear strategy, we basically just flip the graph of these two over the x-axis. So that means we flip the side of the payoffs. So the graph of the bear call spread payoff should be the image of the put call spread payoff over the x-axis, and similar for the bear put spread. See that? And also the shape of the two bear spreads are similar, like shifting one graph vertically to obtain the other. Therefore, the profits are expected to be the same. Now let's consider a ratio spread. A ratio spread is constructed by buying M calls or put at one strike and selling N calls or put at different strikes, with all options having the same maturity and underlying assets. And here we don't need to guarantee whether K1 and K2 which one is greater. Alright, so now example 2. You are given that the price of 2 years call option on a stock are 2.47 call premium for 40 strike and 7.42 call premium for 50 strike. The continuous compounded risk-free interest rate is 5%. Calculate the maximum payoff of the ratio spread formed by purchasing a long position in 2 units of 50 strike call and short in 3 units of 40 strike call. So here, this is a problem of call, right? A problem call, and we purchase 2 call and we short 3 calls. So the payoff here, remember for a call, the payoff is ST subtract K plus, right? So first for the 2 units of 50 strike, the payoff should be 2 times with S2 minus 50 plus. And for the short, the payoff for short in 3 units of 40 strike call, the payoff should be minus 3 S2 minus 40 plus right here. So now we can just consider 3 different cases when S2 is less than 40, when S2 is between 40 and 50, or when S2 is greater than 50. So by doing so, we obtain the payoff function should be either 0 when S2 less than 40, or 120 minus 3 S2 when 40 less than S2 less than 50. Or it should be 20 minus S2 when S2 is greater than 50, right? So the max payoff in this case should be 0. The last spread we want to consider here is a butterfly spread. A butterfly spread is constructed by involving position and option of the same type with 3 different strikes, K1, K2, K3. Here we can have either 3 of them are calls or 3 of them are put, but we need to consider the same type. We're not going to miss a put and a call in this case. We define a ratio lambda is equal to K3 subtract K2 over K3 minus K1. And from here we solve for the meter strike. K2 should be lambda K1 plus 1 minus lambda K3, and 0 less than lambda less than 1. So here you see K2 is on the left side, K1 and K3 on the right side. So we think about, what about we buy K1 and K3 and sell K2. So we consider a long position in butterfly spread that we buy lambda calls with try K1 and 1 minus lambda calls with try K3, and then sell 1 call with try K2. Now we consider this table. Here we got 3 different tries. So we have 4 different range, 4 different intervals for the stop price. And we long lambda calls with try K1, short 1 call with try K2, long 1 minus lambda call with try K3. Remember, when you do short, you have to have minus sign in front of everything. So let's consider the first one, long lambda call with a try K1. Here, when the stock price is less than K1, then the payoff is 0. When the stock price is greater than K1, the payoff should be lambda times with Ft minus K1. See that? So it's 0 at the first place and lambda times Ft minus K1 at the other 3 place. Remember, this is a call, so the payoff function is Ft minus K plus. For the put function, we got K minus Ft, but for call function, we got Ft minus K. Now, when we consider the second one, short a call with try K2. So K2 is the number we are considering. When the stock price less than K2, we got a payoff function is 0 with the negative sign. When the stock price is greater than K2, we got Ft minus K2 with the negative sign. So the first 2 places are 2 zeros, and the last 2 places are minus Ft minus K2. Now, if we long 1 minus lambda call, we'll try K3. So K3 is the number we are considering, right? When the stock price is less than K3, then the payoff is 0. When the stock price is greater than K3, we got Ft minus K3, and don't forget to time with the number of units that we long. That is 1 minus lambda. Now we aggregate by adding column by column in order to find the payoff. For the first case, when the stock price is less than K1, the payoff should be 0. For the second case, when the stock price between K1 and K2, we got the payoff should be lambda times Ft minus K1. When the stock price between K2 and K3, we got lambda minus 1 Ft minus lambda K1 plus K2. And then don't forget one more thing, that is lambda K1, the relationship between K2, K1, and K3. Remember, K2 is lambda K1 plus 1 minus lambda K3. So K2 minus lambda K1 is 1 minus lambda K3. So the last 2 terms here make up 1 minus lambda times K3. And then factor 1 minus lambda outside, we got 1 minus lambda times Ft minus K3. So this is the payoff for the third case. And the last one, we add them together, they automatically cancel out. So this one should be 0. You can try it. When you add together and using this relation, K2 is equal to lambda K1 plus 1 minus lambda K3, this sum should be 0. See that? So the payoff function is a piecewise function, consists of 4 different cases. See that? Alright, so that is half of the lesson. I will continue to finish this lesson on the next video. By the way, I want to introduce the textbook that I use to make the lecture here. That is a text study manual for SOA exam IFM in 2020. Alright, thanks so much for your time. Alright, thanks so much for your time. Hope to see you guys on the next video. Bye bye.